Hello, this is my demonstration for the CS6250 course Isosurface extraction assignment. In this video, I'll be using the OUNPPM visualizer, which stands for Ohio University's Navaids Performance Prediction Model. The OUNPPM source code provides a 3D dimensional environment for visualizing instrument landing system field data such as localizer and glide slope signals. It loads field strength values from the .dat file and creates .output intermediate file, and then it includes tool for rendering isosurface so we can analyze how the signal behaves in space. This visualizer was originally designed to study how ILS signals are affected by terrain, buildings, and aircraft. It creates a full 3D scene, including the runway, antennas, scatterers, and grids. For this assignment, I'm using it specifically to show how isosurfaces are extracted and displayed. Now let me begin with what an isosurface is. An isosurface is a 3D surface representing all points in the volume where the field equals a chosen value, in this case the signal strength. It is a 3D equivalent of a contour line and a 2D map. The OUNPPM tool uses isosurface to highlight areas where the navigation signal strength reaches a certain threshold. How isosurface extraction works. When I choose a signal strength, the program subtracts that value from each sample point in a 3D grid. Then it checks each grid cell. If all 8 corners are on the same side of the ISO value, nothing happens. If some corners are above and some are below the value, that means the isosurface passes through the cube. The merging cubes algorithm determines how to draw the correct triangle pattern for that cube. All triangles from all cubes are combined into a mesh, and that mesh is the isosurface we can see later. Now let me explain the GUI in the ONPP visualizer. There is a drop down for scenario. The scenario dropdown selects the spatial grid layout. Each scenario defines different X, Y, Z for sampling, and some represent ideal cases like ideal glide slope and ideal localizer, and other includes Boeing 777 or with a hangar. And there is another dropdown for field. The field dropdown lets me choose which data field to visualize, like CSB CRS, SBO CRS, CSB CLR, SBO CLR. CSB stands for carrier with sideband, and CRS for core signal, and SBO is for sideband only, and CLR is for clearance signal. And there is a browse for dat file button, which allows to select the dat file that can be used for isosurface extraction. If I click on this button, the file browser will open and allow me to pick a .dat file from the system. It allows only the dat file, and if I click on the button, if I select the file name will be displayed in the selected dat file section. And there is another button for init. The init button loads the selected scenario and prepares the visualizer for processing the selected dat file. And there is another button, generate output. If I click on the generate output button, it calls the external DLL, which computes the electromagnetic field strength and generate the intermediate .out file. If I click on the parse output button, parse output loads the field values from the .out file into a 3D array used for isosurface extraction. And there is a parse CDI button, which loads alternative field data from CDI files when needed. And here is a signal strength and generates signal isosurface button. If I select if I click on init, generate output, and then parse output, it will pass the signal strength, and if I can enter numeric value for the signal strength that serves as a ISO value and generates. If I click on the generate single ISO surface button, it will generate the ISO surface having that value. We can see in the screen that uh, isosurface is being generated where the signal strength is mm, e to the power minus 4. Like if I increase or decrease this value and hit the generated single isosurface, we can see that isosurface is being changed. This is the what isosurface looks like for ideal glide slope with e to the power minus 3 as a signal strength. And if I decrease this value, let's say for e to the power minus 5, we can see that there is a different isosurface, and the start, stop, and ink defines the range of iso values. Generate isosurface. If I hit the generate isosurface catch, it will pre-compute isosurface across that range and stores them in the catch. And if I click on animate isosurface sketch, you can see that isosurface is being animated for different ISO values, and there is a button to stop animation, and the save toggle button swaps between the current ISO surface and the previously saved one. This is useful to compare save, and change detection compares most recent datasets and updates the ISO values to the average fuel strength of the selected component. And then there is a export button which export writes the current isosurface to a text file. It generates mesh indices and vertex list, and let me try different isosurface with the glide slope. Let me select other file. If I go to the browsed for that file and click here, I can go one folder back, and there is folder named data. Sorry. In the data folder, I have different dat file. Let me select the ancient data, and if I hit init, generate output, and then parse output, and if I click generate single isosurface, we can see that there is a very tiny isosurface in here. Now let me increase the signal value to e to the power minus 4. You can see that there is a different isosurface than the ideal Kleistler one. Let me do higher signal. Yeah, it looks like completely different signal. Uh, I can do this with the localizer. Let me select ideal localizer and then browse for the ideal localizer, the dat file. It's in the data folder, ideal localizer, the dat, and I need to select init, generate output, and then parse output. Then I can use generate single isosurface. We can see that localizers output in here. If I let me decrease the signal strength to e to the power minus 4, and we can see that isosurface is changing. It also changes with the field type. Like if I select the goes to clearance, the isosurface will change. And let me select one more file which is kind of a glide localizer data but with a different antenna. antenna with WI14-10 antennas. Now if I click on init, generate output and then parse output and generate single isosurface, we can see that isosurface looks completely different than the ideal glide slope. If I increase the signal intensity, yeah, it looks like it doesn't have higher intensity, higher signal strength. Now let me decrease it. If I decrease, there is a little kind of isosurface in here. Now let me select another dat file with, let me select the antenna with WI14-6 init, generate output and then parse output, and if I hit single generate single isosurface, yeah, there is a little bit of isosurface having signal strength e to the power minus 5. If I increase signal to e to the power minus 4, we can see that there is more surface to display, and I can move around the world and look at how the signal isosurface looks like from different sides. To extract the isosurface, it uses the marching cubes algorithm. That's all for my isosurface extraction assignment. Thank you for watching.